Now we'll talk about point-slope form. After this section, you will be able to find the equation of a line two different ways, given a point and a slope, or just 2 points, and you'll have to figure out the slope. The other forms that we've used for linear equations are slope-intercept and standard form. Slope-intercept, y equals mx plus b, graphs a line where you know the slope and the y-intercept. Point-slope form does not rely on knowing the y-intercept. You don't have to know where it crosses the y-axis to use point-slope form. I have seen point-slope written different ways. Here's the way we're going to use. Y minus y1 equals m times the quantity x minus x1, where m is the slope and x1, y1 is a point that's on the line. So the m number is going to get taken out and the slope will be put in there. And y1 and x1 will be taken out. And the coordinates of a point will be put in there. The y and the x will stay in as the y and the x that's in our equation. So like an example might be, let's say I had a point that was 3, 4, and I knew the slope was 2. The point-slope equation would look like this. Y minus the y1, which is 4, equals the m number, which is 2, times x minus the x coordinate of the point that we know, 3. So that's how point-slope form would look once you subbed all the pieces into it. Some other ways I've seen point-slope form written. Sometimes these two are basically the same thing, except instead of using x1, y1, they use hk. I think so the subscripts don't mess you up. But notice that these two are actually really the same. All they've done here is they took this piece and added it to both sides, which moved it from here so you just have the y equals, and then now that plus y1 is just on the other side. So it puts it all on the same side for you. That's the only difference between the first two. Let's look at how to use this. Find the equation of the line that goes through the point 2, 6 and has a slope of 2/3. Before we get started, let's take a look at what this line will look like. We know that it goes through the point 2, 6, so make a dot at 2, 6. We also know that it has a slope of 2/3. Usually we do the slope from the y-intercept. That's our starting point. Since we don't know the y-intercept, we'll just do our slope from right here, the point that we do know. So just up 2, right 3, make a dot. Do the same pattern backwards. Down 2, left 3, make a dot. So there's our line. So first, let's decide what form would be appropriate. To use the slope-intercept form for graphing a line, you need the slope, you need an m number, and you need a b number. That's the y-intercept. So you look at your problem. Do you have a slope and a y-intercept? No. What do you need for point-slope form? Well, you still need the slope, the m number, but then you also need one point that's on the line. We're going to name that point x1, y1, and that's what we have. We have a point that's on the line and the m number. So our point is 2, 6, and our slope, we're given that the slope is 2/3. So our m number will be 2/3. Our point, the x coordinate, or x1, will be 2, and the y coordinate, or y1, will be 6. So now we just take point-slope form. Y minus y1 equals m times the quantity x minus x1. And we just sub our stuff in there. Let's see, the y and the x are going to stay in the equation. So we'll have y minus y1, that's 6, equals the The m is 2/3. The x stays, minus x1, the x-coordinate of our point is 2. So right there, I've got point-slope form. I want to show how to change that into slope-intercept form. I'm going to do some fraction math kind of quickly. Feel free to stop the video and do them out as decimals or use a fraction calculator to figure out the fractions. Okay, so first thing, I'm going to change this by simplifying into slope-intercept form, y equals mx plus b. So the first thing I'm going to do is distribute. So I get 2/3 x, and then 2/3 times 2, I'll make this into a fraction, multiply the tops, multiply the bottoms, so that's 4/3. Is equal to y minus 6. Now I want to move that -6 over. So I'm going to add 6 to both sides. So let's take a look here. I'm going to have to add -4/3 and 6. Instead of -4/3, just to help me with the fraction math, I'm going to think of this as -1 1/3. Okay, so let's see. On this side, I've got just a y, because the -6 and 6 cancel, equals 2/3 x. Now let's see. -1 1/3 plus 6. So let's see, if I add 6, if I take away 1, that's down to 5. If I take away another third, that is 4 and 2/3. So this is now in slope-intercept form. Y equals mx plus b. Notice the m number, that's the slope, and the b number should be where it crosses the y-axis, which is right there. So again, to get from point slope to slope intercept, all you have to do is simplify. Find the equation of the line that connects these 2 points. -1, -3, it's right there. And 2, -9. Oh, it's off our graph 1. So that's our line. We are going to find the equation of this line. So first of all, what form should we use? Well, we're going to use point slope form, and here's why. To use point slope form, you need a point and a slope. We've got 2 points actually. We don't have a slope, but as long as we have 2 points, we can find the slope rather easily. Why not just use slope-intercept form, y equals mx plus b? Because we don't have the b number. We could get a pretty good guess from our graph, but we'll use point slope form here. So in order to use point slope form, we're going to need at least 1 point. We've got actually 2, and the slope. The first thing we'll have to do a little work to get is our slope, because we don't have the slope right now. But we can use our slope equation to find the slope. We'll take our 2 points and label them. Over here, point 1 will make the x-coordinate be x1 and the y-coordinate be y1. And point 2 will have the x-coordinate be x2 and the y-coordinate be y2. We'll sub those in. So y2, it's -9, a minus from the formula, and y1 is -3. I have two minus signs because I have one from the formula and one from the -3 that I subbed in. x2, it's 2, minus x1 is -1. Remember that anytime you minus a negative, it turns to addition. So this is really -9 plus 3 over 2 plus 1. So I've got -6 over 3, which is -2. So that's my m number. That's my slope. So now I've got the slope. It's -2. And I've got my point. Now I'm going to have to choose one of my points to use. It doesn't matter which. It'll come out the same either way. I'll use point 1, -1 and -3. Sometimes I try to use the one without negatives, since negatives mess kids up, mess students up, but this one all has negatives. So now I will use the point slope equation to find the slope of my line. Find the equation of my line, rather. Remember, the y1, m, and x1 are all going to come out for stuff that we know. The x and the y will stay there. So y minus the y1 was -3. The m, our slope, was -2. The x1 was -1. So I'll simplify this. Subtracting a negative is the same as adding. So I've simplified a bit, and what I have right here is point slope form. This is the point slope form of the line. Now I can simplify this to turn this into slope-intercept form. First I'll distribute. And then I'll get the y by itself by subtracting 3 from both sides. So this is my slope-intercept form. Now let's check that against my picture. I should have a slope of -2, down to right 1. And I should have a y-intercept of -5, which I do. So, point slope form of my line, slope-intercept form of my line.